Hi, my name is Albert Tai.
My name is Christopher Kim.
And I'm Jae Song.
And we have elected to call ourselves the Airbenders because our perpetual machine uses air propulsion technology. Now, we begin by firing a ping pong ball through this gear-powered cannon into this laser-cut funnel. It goes across this Ferris wheel, powered by a motor, and into this elevator, where a pump elevates it to this level, where it proceeds through this maze, goes down to this contraption, which is powered by wind. The legs move when wind blows on this fan, and then finally, it goes back into this cannon. A more challenging aspect of this build was this cannon right here. Now, we started off by designing some of these gears in AutoCAD. We had to give this one a longer moment arm because there was in fact not enough torque to activate the cannon from this motor. So we did that. Gearbox right here. We have a rack and pinion that will pull this dowel backwards, and the force of the balloon will snap it back. To know when the cannon will fire, we have a photoresistor here, which emits a laser. When that laser is crossed, that tells us when the cannon is going to go off. Another challenging aspect of this build was this elevator over here. The elevator is powered by this pump, which lets out a stream of air and pushes the ball up the shaft. Now, we know when to trigger this elevator when a photoresistor's laser is crossed, just like the cannon. It will do so in this fashion.
Oh, hello. I didn't see you over there. My name's Wayne Lewis.
I'm Kali Orupa.
I'm Zachary Feliciano.
And I'm Sarah Benitez.
We're the Fantastic Four. For the past 5 weeks, we've been working on this Rube Goldberg design based off New York. You see, we're using marbles. Marbles are like passengers. From here, it starts off on this catapult, which is going to be much like a bridge, which is going to throw it all the way to this funnel. You never know when the funnel is going to release the ball. From here, it's going to have the marble go step by step toward a pathway, which it will eventually reach its taxi.
So here we have the catapult that we built. It took us about 2 weeks to build. The way it works is we have a gearbox that we salvaged with, and we attach the cam and a dowel to the gearbox. And the cam has a drop, so the spring and the rubber bands under here, they're here for resistance, and all the energy stored in here when the catapult drops is released and the ball launches into the funnel.
This is our camshaft. We've been working on this since the first week of the program and has gone through many prototypes. So here we have 6 steps which sits on top of a cam. Each cam is alternating in the direction it's pointing through. And so what happens is when you spin the dowel, the wooden block goes up and down like an escalator.
By watching this marble, you could enjoy all the pleasures of New York just by watching. Have a great time. And
Hello, my name is Jared.
I'm Anna.
I'm Grayson. I'm Joe.
And we're the Clever Quartet. This is our final project. Our final project has 4 steps, and we use a steel ball bearing which has a diameter of about 3/8. And first, the ball will start here in this elevator we have. And as it rotates, there's a smaller dowel that will keep it in place, while the larger dowel in the middle will go and rotate and bring the ball up. Once it reaches the top, there's a magnetic track that brings it to here, our Plinko board. As it rolls down the Plinko, it will get into this heat disperser that we found in a printer. Next, the ball will travel across this PVC track that brings it to these steps here. The steps will bring the ball up, and it'll drop off into this funnel and bounce on these 2 trampolines onto this magnetic track back to the elevator. Okay, our machine starts here with these steps, and the ball rotates, goes into this funnel, goes into these trampolines, and it goes onto this magnetic track that goes into this elevator. As the ball rotates up, it goes onto another magnetic track, goes down this Plinko board, onto this PVC track, and back to the steps here. A few difficulties we had with our project was first that we had our project on a 16 by 16 pedestal here. Another one is the elevator. We had trouble having the ball going onto the little platform and getting it off. We solved this by using these magnetic tracks that will attract the steel ball bearing, so it will help it come off and on. Another problem we had was these trampolines here. Trampolines, we had difficulty having to place them in the exact position we wanted them to be so that the ball will bounce on, correctly on each of them.
We are the Clever Quartet, and this is our project.
Hello, my name is Suro Yu.
My name is Jen Kim.
I'm Risa Parham.
And I'm Harvey Chung.
And we are the LE4. So this is the Ferris wheel right over here, and it's powered by a motor located right here. And as the gear moves, the Ferris wheel also moves, and then the ball bearing falls down here, in turn goes over here. And as the steps move forward, the ball comes out of here. As you can see, the tracks are made of acrylic and wood. And as it falls down here, there's another step, and it also rises. Over here, it goes right there, and this is a teacup model, and as it spins, it's gonna fall out of a hole located in the bottom.
This ball falls down into this cup and is stopped by the clear plate here. When the gear turns, falls down into the cup below, and it travels along the planetary gear until it reaches a hole on the opposite side, where it falls out.
So this is the Ferris wheel, and as you can see over here, it's powered by motors. And if you look over here, there's a cord that separates the gear and the motor. And before we didn't actually have any gears, but due to time interval problems, we put gears. And as this turns, the gear turns the Ferris wheel. And later in the process, the marble falls down into one of the cars. And then if you see this funnel right here, the car stops it, and then it falls, and then it leads into the steps.
Okay. Hi guys, this is our group. I'm Hongjae. This is my group member Tenzin, Penshi, and Tong. Our group theme is Zoom. You can see each part of them made by the animal, giraffe, monkey, snake, and fish. First of all, the ball will catch by a hook going through to monkey. The monkey's hand the box while moving around, and the ball will catch into the snake body, which made by trunk. Ball will going through the snake. Snake will get into the funnel into a fish. Fish get into the trunk. Trunk coming to the last step, cam. Cam will carry the ball through into our first step, giraffe. Yeah. This part is made by pulley system. You can see here is 1, 2, 3 different pulley handling by the RoboBell. So this RoboBell handing here with another robo, it can rotating, make the robo rotating, and the hook can hook up the ball. But during this process, there's a problem. That which means is the distance between two pole system, so that we gotta make it really tight. As you can see here, with nail here, so that this tight can fix 3 of those poles, so that the RoboBell can rotating really fast by the motor we're using here.
Hi, I'm Sunam, and my team members are Shui, Shane, and Chandler. The theme of our project is gears. The entire process is continuous, and we're using a 0.5 marble for it. It all starts from the sky wheel, which is spinning. At the top of it, there's a pinch, which lets the marble roll down the tube, and it drops on the T-nails, which drops on the ramp, and it goes on to the rotor, which helps the marble to elevate to the maze. And it enters the maze, and the maze is spinning, so in the center of it is coming out to a ramp, which is going back to the first stage, which is sky wheel. This is maze, and we AutoCADed it and then laser cut it to get the shape that we want. And we also use the plastic cover to prevent the ball from falling. And we use gears at the back of it to spin with the help of the same motor for the entire project. Ball rolls through the maze, and it goes in the circle, and then there's a ramp.
Hi, my name is Shirin. This is Anup, this is Hongju, and this is Idrisha. Our project was based on a water park. The theme is the water park. So first, this is where it all starts. The ball is gonna be here, and then it goes up, and it moves from here. This is the water slide, and then the ball goes from here, and then comes back, and then goes right back here. So there is a water running throughout the project. It continues to run, and the water falls down and turns a small water turbine. When this turns, it will turn this wheel, and as the wheel turns, we have a switch button here, and the lights goes on. Mechanism behind this one is that we have a motor. The motor turns this gear, and as it turns, the ball goes up, and the ball goes around here. A submersible water pump, which continues to push the water up here, and then it keeps going. The water keeps running. The lights are connected in parallel because the first time we did it with series, the voltage kept decreasing and the bulbs kept going dimmer and dimmer. So we had to do it in parallel to keep the voltage same throughout the.
The most challenging part of the project was making the water slide water sealed, and so in order to make it water sealed, we put the silicone around the joining so that the water won't leak out while the water flows through it, and also the cutting all these PVC pipes. And yeah, cutting them was another difficult part of our project. But yeah, we tried hard, and here we have it. Yeah.
Hello, this is Timo Predictable. I'm Linda. He's Colin. This is Katie, and this is Ayushi. Our project is basically the basketball project. You drop the ball from here. There's a trampoline. It goes into this barrel cover. Then they have the motor that triggers us into the basketball hoop. Then from there it goes onto the ramp. From the ramp it goes into the track, straight to the elevator. Then from the elevator the ball pushes up to the escalator. Then it goes back onto the trampoline.
Okay, so one of our most difficult parts was this basketball guy, which is basically a catapult. Now how it works is that this camshaft is turned by a motor, which pushes up his arms, which are then held by these rubber bands. When it reaches its maximum height, it snaps back down and catapults the ball from the basket into this hoop over here. Why this part is so difficult is because you have to calculate the right angle and right amount of force you have to apply in order to get the ball from here to the hoop 100% of the time. This is our escalator system. It is just like any other escalator that you may find in a supermarket or a mall. As the ball comes up from the elevator, it rolls down this little ramp into this belt. And as it rolls, this escalator turns and deposits the ball out of a little slot here, which then drops it onto these series of trampolines, and that's how this works.
Thank you for watching.